Welcome to 5.6 half-angle identities. We are going to start by deriving the power-reducing identities for sine and cosine. We are going to use the identity for cosine of 2a, and I will start with 2 cosine squared a minus 1, and we're going to solve for cosine of a. So go ahead and pause if you want to try it. So to solve for cosine of a, we first add 1 to both sides. Cosine 2a plus 1 equals 2 cosine squared a. Now divide both sides by 2. Notice we can cancel out these 2's since this 2 is just being multiplied by cosine squared a, and the multiplication cancels with the division. This is a power-reducing identity for cosine, and in this course, we will not be using this exact identity. However, it is used in pre-calc and calculus. We will also be utilizing it to get our half-angle identities, which we will be using a lot in this course. Now we're going to do the same, but now we're going to still use cosine of 2a, but with the sign. So 1 minus 2 sine squared a. So again, feel free to pause to try and solve for sine of a. I will put the -1 in front. Now we divide both sides by -2. Now to rewrite this left-hand side, I'm going to go ahead and multiply the top and the bottom by a -1 because we don't normally like to leave a negative in the denominator. So we get sine squared a is the quantity 1 minus cosine of 2a divided by 2. Also, oftentimes the cosine of 2a and 1 are switched, so these look more similar. So therefore, we have our power-reducing identities. Cosine squared a is 1 plus cosine of 2a all over 2, and sine squared a is 1 minus cosine of 2a all over 2. Now let's derive the half-angle identities using the power reducing identities, but what we're going to do is we're going to replace a with a b over 2. So for the cosine power reducing identity, we're going to replace a with b over 2. We get 1 plus cosine of 2 times b over 2. All of that over 2 equals cosine squared of b over 2. So we can simplify the 2 times b over 2. The 2's actually cancel. So we get 1 plus cosine of b all over 2 equals cosine squared of b over 2. Now we're trying to solve for this cosine of b over 2 because we want our half angles solved for. So we're going to do the square root of both sides, but don't forget the plus or minus. This is our half angle identity for cosine, where we get cosine of b over 2 is plus or minus the square root of 1 plus cosine b all over 2. Now let's do the same for the power reducing identity of sine. So we get 1 minus cosine of 2 times b over 2 all over 2 equals sine squared of b over 2. Again, we simplify the 2 times b over 2. 1 minus cosine b over 2 equals sine squared b over 2. Square root both sides. Don't forget the plus or minus. So our half angle identity for sine is sine of b over 2 equals plus or minus square root of 1 minus cosine b all over 2. Now to derive the half angle identity for tangent of a over 2, we're going to just do sine of a over 2 over cosine of a over 2. So we get the half angle identity for sine over the half angle identity for cosine. Notice the similarities between the half angle identities for sine and cosine. They are almost identical, except the half angle identity for sine has a minus and the half angle identity for cosine has a plus. Because the numerator and the denominator are both under the square root, this can be brought into one big old square root, where we have 1 minus cosine A over 2, and all of that is over 1 plus cosine A over 2. The 2's cancel. So we get our half angle identity for tangent is plus or minus square root of 1 minus cosine A over 1 plus cosine A. This version of the half angle identity for tangent is the one that I commit to memory the most because you can see the connection between the sine over cosine. However, there are two other versions of the half angle identity of tangents that are nice to work with. So again, we'll start with that sine of A over 2 over cosine of A over 2. Now this next step is a little contrived, but what we're going to do is we're going to multiply top and bottom by 2 cosine of A over 2. So on the top, we just get 2 times sine of A over 2 times cosine of A over 2. On the bottom, we get 2, and then the cosine times the cosine of the same value is cosine squared. So we get 2 cosine squared of A over 2. In the numerator, we see this form 2 sine A cosine A is the double angle for sine. So really, that's going to be the sine of 2 times the angle being A over 2. The denominator is a little trickier. Notice we have this 2 cosine squared A minus 1 is the cosine of 2A. If we add 1 to both sides, we get 2 cosine squared A equals 1 plus cosine of 2A. So since here we have a 2 cosine squared of something, then we could write that as 1 plus cosine of 2 times that something. That something is A over 2. And notice both of these, the 2's cancel with the A over 2, and we get sine of A over 1 plus cosine of A. So this is a second half angle identity for tangent, which is sine of A over 1 plus cosine of A. I feel like these two are sufficient. I feel like this one's easier to work with computationally, and this one's intuitive from the sine over cosine. However, there is a third, and so I'll go ahead and show you this derivation, but know that really these two are usually sufficient. So the way we get the third version is we just take this identity here and we multiply top and bottom by the conjugate of 1 plus cosine A. So we'll multiply top and bottom by 1 minus cosine A. I'm going to leave the sine of A factored out. In the denominator, we have 1 plus cosine A times 1 minus cosine A. We'll get a difference of squares, or 1 minus cosine squared A. We'll replace that with sine squared A using the Pythagorean identity. And now one of the sine A's will cancel in the numerator and denominator. So we end up with the 1 minus cosine A up top and sine A on the bottom. I hope you enjoyed the video. See you next time.